Imagine just telling your digital assistant to go out and buy you a new jacket, and it handles the entire payment seamlessly, securely, and completely on its own. Well, today in this explainer, we are diving deep into the rapidly evolving infrastructure that is actually making this a reality. We're looking at how AI agents are finally able to hold and spend real money. So you might be familiar with the classic 404 error, but do you know the HTTP 402 payment required status code? Yeah, for almost 3 decades, it has sat completely dormant on the web. It was literally just reserved for future use back when the internet was still young. But what happens when we finally wake it up to solve a massive problem with how machines transact? Well, the answer is an entirely new, invisible economy. To get a handle on all this, here's our game plan for today. We'll cover the 402 awakening, dive into machine-to-machine micropayments, tackle the human delegation problem, unpack the protocols for AI shoppers, and finally, look ahead to the future agentic economy. Let's get right into it. Part 1, the 402 awakening, and exactly why our traditional payments are failing AI. Think about traditional payment platforms for a second. They typically hit you with a flat 30-cent fee per transaction, right? And that's totally fine if you're a human buying, say, a $20 book online. But imagine an AI agent trying to make a tiny data request that only costs a single penny. That 30-cent fee immediately puts you at a negative 3,000% profit margin. It literally breaks the math for machine-to-machine interactions. So to fix this, Coinbase developed the new x402 protocol. Instead of those clunky, flat fees, an AI can pay exactly 1 penny, often using a stablecoin like USDC, for a single API call. There's no massive subscription to sign up for, no complicated human invoices to deal with. The agent just pays for exactly what it consumes, right down to the fraction of a cent. Moving on to part 2, machine-to-machine micropayments, or what's quickly becoming an invisible economy. There's this fantastic quote from the YouTube channel Fireship that says, "Turn every API request into a tiny cash register." And honestly, that hits the nail on the head. That is the ultimate goal here. By leveraging x402, developers can finally achieve instantaneous, frictionless payments with zero fees. Machines can trade data for pennies at absolute lightning speed. So here is how it actually flows in practice. An agent requests some data. Normally, it might hit a hard paywall. But here, the server simply blocks it with that revived HTTP 402 code. Immediately, an open-source tool, like Pearl for instance, intercepts that block, auto-pays the fraction of a cent via a connected crypto wallet, and boom, the data is returned. The whole shebang happens in milliseconds, completely invisible to us humans. Let's shift gears to part 3, the human delegation problem. Specifically, what happens when AI starts buying physical goods? You see, today's banking systems assume a human being actively clicked the buy button. But what if your autonomous AI agent hallucinates and accidentally orders 500 rubber ducks to your front door? Who is accountable for that? Is it you, the user, the merchant, the bank, or maybe the AI model itself? Without a clear line of accountability, banks simply aren't going to trust AI shoppers. And that brings us to Google's answer to the problem, AP2, or the Agent Payments Protocol. It's essentially a cryptographic framework that shifts the entire system from inferred action, where merchants kind of just have to guess what an AI is allowed to do, over to verifiable intent. It's backed by hard math, meaning everybody knows exactly what the AI is actually authorized to purchase. Which leads perfectly into part 4, protocols for AI shoppers, and how we actually secure these transactions. So AP2 solves this massive security headache by compartmentalizing the risk into specific roles. You have the shopping agent, like Gemini, which figures out what you want and builds the cart. The merchant endpoint negotiates the details. But here is the absolutely crucial part. The shopping agent never actually touches your credit card numbers. A totally separate credentials provider acts as a secure vault, keeping your sensitive data miles away from the AI itself. And how do permissions work? They're based entirely on your availability. If you're sitting right there at your screen, you sign a cart mandate to approve an exact purchase. But if you're fast asleep or offline, your AI operates on an intent mandate. This sets very strict boundary conditions, kind of like giving it permission to buy concert tickets, but strictly capping the price at $100. This straightforward 4-step flow turns a simple checkout into a rock-solid secure contract. The merchant guarantees the price, you sign the mandate, and the transaction executes. This creates what the industry calls a non-repudiable audit trail. Now, that is just a fancy way of saying there is mathematical, undeniable proof of who authorized what. Nobody can point fingers if a dispute ever comes up. Now, Stripe is building something very similar using shared payment tokens. Think of it a bit like giving your AI a highly restricted temporary gift card. You pass your payment intent to a seller with strict limits, maybe a tight spending cap or a set time expiration, and you do it all without ever exposing your actual bank details to the open internet. It processes natively right within Stripe. So let's play this out. Say your AI miscalculates, or a shady merchant tries to sneak in an upcharge. If the agent tries to spend $50 on a token that you explicitly capped at $25, Stripe certifiably enforces your rule. The transaction is instantly declined, your money stays completely safe, and you, the human, remain in ultimate control. And finally, part 5, the future agentic economy and the vision for a truly seamless web. I want to leave you with a bit of a provocative thought today. As protocols like x402, AP2, and Stripe Agent Commerce continue to mature, machines are going to negotiate, audit, and transact in the background faster and cheaper than we ever possibly could. So how long until typing a 16-digit card number into a clunky web form becomes a total relic of the past? The machines are finally learning how to pay, and honestly, the internet will never be the same. Thanks so much for joining me on this explainer. I hope you found it as fascinating as I did.